Hello everyone, my name is Menvir Dhillon and I am looking at the question on how does lithium mining contribute to domestic water shortages in Northern Chile. So a little bit of background on me. I'm an undergraduate at Imperial College London. I'm in my first year and this is my sort of first presentation I've done. I'm an earth and planetary scientist with a particular interest in sort of hydrogeology and mining, which is why I sort of thought of the question, and I'm interested in sort of debating public policy, and so may want a career in sort of combining mining and public policy and looking at working in UNEP. So why this question? So this question doesn't really, there's not much information about lithium mining in Northern Chile. It is mostly copper based. And this topic is of global interest in an era of anthropogenic climate change. So yeah, so lithium is becoming increasingly important. These statistics show that due to the fact that we are transitioning to a more cleaner, we're using more cleaner methods, we will require the extraction of metals like lithium. There has been more research done into examining how lithium, like sort of recycling lithium batteries. However, evidence has now been, sorry for the noise, sorry. There has been evidence which suggests that that lithium mining does not, that that lithium recycling cannot satisfy the demand that that will be needed to for that will be needed for lithium. Um, and so, sort of why Northern Chile? So Northern Chile accounts for 48% of all lithium reserves in the world, of which most of that is in the northern part in the Atacama Desert, and Chile is part of the Lithium Triangle. And so the region is lithium is concentrated there due to the fact of the Andean orogeny leading to low erosion, leading to orographic effects, and leading to the formation of the brines. And after the Pinochet government, the lithium mining became more privatized and shared by two companies, SQM and Albemarle. And majority of, and 2/3 of lithium mining is done through brine extraction. So the current technology with brine extraction requires sort of the evaporation of water, and the evaporation of water leading to lithium to become more concentrated. Once it reaches a threshold of 6,000 ppm, it then goes through the refining process, whereby the recovery plant, whereby brine is treated with lime to precipitate the magnesium cations and with organic solvent to remove the borates. Lithium carbonate is then precipitated via the addition of sodium carbonate, and that then forms the concentrated lithium. And so the impact of groundwater reserves. So the satellite imagery here showcases that within the 5-year span, the water lagoons of the aquifers in northern Chile have essentially have reduced dramatically to the point where there are some which aren't visible. And so the reason for that is because 95% of all extracted brine require, like 95% of the water is removed from lithium brine, and not only that, but lithium that fresh water is also required for the machinery to clean the machinery, and so that in combination with the fact that you're losing the brine extraction is removing the water is resulting in the water loss. And so when we're looking at sort of the effects of depleted water reserves, Chile is one of the driest regions on Earth, and is leading to multiple impacts on both the people and the flora and fauna. So the big thing is that in the Atacama Desert there are many endemic species, and these species are at risk of extinction due to habitat loss. In addition, indigenous communities are at threat from their loss of their cultural traditions, causing them to move more into cities like Santiago, and that is resulting in a loss of cultural traditions and cultural degradation. And I think one of the most interesting ones is the microbial activity. So there has been recent discoveries of stromatolites in not only in northern Chile but around the Lithium Triangle, and the northern Chile is one of the only few places whereby stromatolites are found both fossilized stromatolites and living day stromatolites are found. And so the removal of habitat is leading to a reduction, may lead to a reduction in these stromatolites. And that is concerning because a loss of these stromatolites may mean a loss of research, and as stromatolites are key to the understanding of the history of the past, we are potentially losing out information through brine extraction. We are losing the potential loss of information and sort of understanding the history of our planet and potentially the history of other planets. And then also another one of the effects is waste. So waste is removed. During the brine extraction, lithium mining is there is an addition of calcium oxide, and that produces magnesium hydroxide and other compounds. And the mixture of those compounds, it means that it's very difficult to separate with the current technology. And whilst it is important to note that this waste is non-toxic, the amount of volume that is produced by this waste is will occupy a terrain of 11.5 kilometers squared, and that eventually the amount of waste that's produced will lead to further actions in the future, which would require removal of said waste. There are knock-on effects of this that brine mining will occur, that will induce. Sorry, and so when we look at all these effects, we see that they are very negative. And I think that sort of comes under the idea of sort of green extractivism, the idea that we will subordinate human rights and ecosystems to do endless extraction in the name of solving climate change. That we are extracting lithium to save climate change, and yet we are causing negative effects for both the flora, fauna, and indigenous communities there. And so I think it's an important thing to note. So when we look at sort of effects of mining, if lithium mining and this form of lithium mining continues in the area, then we are looking at potentially 1.5 trillion liters of water to be at stake. And so this image is a repeat of the previous image. And so you can imagine within only a 5-year time span this happens. So you're looking at a 20, 30-year time span. So there is a real sort of threat, an imminent threat of a loss of water in this region, and that is quite concerning for the indigenous communities there. And so when we sort of look at sort of solutions to sort of do it, one of the main ones is to look at the actual lithium, is to actually sort of recycle the lithium and to sort of extract the lithium without doing the brine extraction. One of the processes is mixed settling, and whereby you will essentially mix the minerals together and then separate by gravity differentiation. The disadvantage of that is that there is increasing evidence that there is severe corrosion and that there is a long equilibrium time. And the link that I have shown you shows many different solutions of the sort of same vein as mixed settling. This presentation would be too long to discuss all of them, so I've just linked them here. However, they generally follow the same problem in the sense that there are many solutions to sort of extract lithium. However, there are negative consequences which aren't really, which on balance would not fix the situation. One solution that I think was quite that I thought was quite good was the sort of integration of a desalination unit. So already there was the sort of so all it would require is implementing a desalination unit alongside the brine extraction, and this would be sort of optimal because there is a high salinity and enormous volume of brine possessed at each facility, and so desalination would be quite useful and optimal. And we can sort of look at sort of desalination programs in when we work in produced water from shale oil and gas extraction, and we can sort of apply the sort of same method, same ideas. And what we can also see is that the sort of desalination unit could also do multiple effects. So one of which could be that the desalination unit would produce fresh water that we can then use in agriculture, and of course the addition of fresh water into agriculture would of course lead to percolation of the water, and you would lead to a sort of replenishment of an aquifer, thus leading to sort of you can maybe argue that the sort of lithium mining will be sustainable in the future. Yeah, but I think the big thing to look at this issue is that there is a real difficulty with solving this issue because of the fact that there is a big degree of interdependency between different factors and different people. So, I mean, one of the big things is that many indigenous communities require the economic activity that mining provides, and that was very evident in COVID-19, whereby the sort of in 2020 the sort of rapid lockdowns, the global lockdown, led to international supply shock chains. And which led to sort of and one of the only sort of places of employment for many indigenous people was was mining. And so if you don't want to necessarily take away the mining, you don't want to necessarily take away the mining to because it may also impact the people who you are trying to sort of help. And so this is sort of showing the sort of difficulty with sort of trying to fix this issue and tackle this issue. And this diagram, the diagram on the right is from UNEP, and it sort of illustrates the point that mining can be well managed. However, as it is now, it is not, and there would be more solutions needed to fix. And sort of the final thing to also talk about in terms of Chile is the geopolitical angle. Chile is sort of, whilst it is the wealthiest country in South America, it is more of a peripheral state, which is more of a peripheral state which produces resources. China has is one of the largest markets for battery grade lithium, and so has strong relations with Chile, and so it is very difficult for It's very difficult for the Chilean government to to stop mining in the aims of trying to protect the indigenous communities. And so I think this project sort of overall highlights that, yes, the reduction of water is leading to the brine mining is leading to a reduction of water. It's having these effects, and many of these effects, we cannot really find many solutions to those effects with the current technology that we have. So here are my references and any questions.